welcome back. Now, the previous video I did walk you through how to really do calculations for a titration problem involving a strong acid and a strong base, in particular a monoprotic strong acid. Now, what we are going to do here is combine some aspects of the previous problem from the previous video and the video before that and put it together as a new video. So here is the problem. So here we have a strong acid. Again, you should always first pay attention to the type of acid and the base. This is a strong acid. This is a strong base. And as I said, I will never give you a chemical equation in any of my courses that is balanced. It may be self-balanced, but I won't tell you it's balanced, which means you need to balance. And if you do this particular problem, you're going to end up with something like this. Well, all we have to focus, this is the play area here, and it's 1:2. So 1:2. This acid is to base, right? Now, I've asked you to find the equivalence point volume. Now, I've given this information. That means this is the acid information, and this is the base information. You know, some of you were confused last time when I spoke to you. M stands for molarity, not milliliters, okay? All right. So how do we find the equivalence point volume? Well, V acid minus, dot C acid equals V base times C base, right? Now, as I said, there should be certain way of writing things which we can change. You see, it's automatic. It's kind of habit. So volume of acid is 25 mils times concentration of acid is 0.5 molar. Okay. Volume of base is what we need to know. So let's call it X. Concentration of base is 0.25 molar. Okay. Now, which side do we put the 2? Well, some of you didn't even know if you put the 2 because, I don't know, this is like the millionth time I'm doing this problem, and probably the millionth time I'm going to do this problem. So your acid's 1, base is 2. So you multiply the acid side by 2. So 2 times this whole thing. Okay, solve for X, and that's your equivalence point volume, which would be, let's do the math, 2 times 25 times 0.5 divided by 0.25. That's 100 mils. So this is the pH. This is the equivalence point volume. Now, there's not a question here, but what if I add a C before we do B? What is pH at 100 mils? Well, 100 mil is the equivalence point volume, right? At equivalence point, if both components are strong, pH equals 7. This is the question, and this is the answer. Now, let's say if it appears by itself, then you still have to do this procedure to figure out if 100 was the equivalence point volume. And if I'm testing this type of idea, then it most likely will be, and pH is 7. All right, qualitatively draw the titration curve. All right, so let's draw 2 lines. One is pH, which is the y-axis, and 14, 7, and 0. And we're adding base into an acid, so volume of base is the x-axis. This is how you construct it, and milliliters in the bracket. Now keep in mind, this is a strong acid, strong base, so it's bottoms up. We're adding base into an acid, so it's bottoms up. But the most important thing is it's a diprotic acid, so we will have, just qualitatively draw. Don't worry about the actual pH inflection point or anything. So just make sure you have 2 inflection points, 1 here, 1 here, because it's a diprotic acid, right? Diprotic. So 2 inflection points. And that's the problem. All right, stay tuned for 2 more videos on the same concept, approaching the same problem from different views. All right, so stay tuned.